Trigonometry is the study of triangles, and it is a branch of mathematics that is very widely used in all different kinds of applications: navigation, space exploration, architecture, medical imaging, building, aviation, surveying, navigation again, woodworking, interior design, all kinds of things. Anything where you need to find lengths or angles or distances, trigonometry is something you're going to use. One of the special things about triangles, we haven't talked about geometry much, but similar triangles are triangles that have the exact same angles, but they might be different sizes. But they would have the same angles, and if they do have the same angles, their sides will have the same ratios. And what you notice on all of these triangles is that the relationship between the side opposite the 30-degree angle and the hypotenuse is always 1/2. And it doesn't matter how big the triangle is or how small the triangle is, if it's got a 30-degree angle and a right angle, which means the other angle is 60 degrees, you're always going to get this ratio. And this characteristic of triangles is very useful, and we'll see how that works out in just a minute. But for example, if you had a kite that you were flying and you knew that your string was at a 30-degree angle to the ground and you had 200 feet of string and you wanted to figure out how high your kite was, it'd be very difficult to find out what that height was without trigonometry. If you have trigonometry, you can remember what we just talked about, and that is in any right triangle with a 30-degree angle, the side opposite the 30-degree angle divided by the hypotenuse is always going to be 1/2. So if you had this situation, you would know that x over 200 is going to be 1/2. Because that's how it is in every right triangle, even a big giant one like this. So 2x would be 200 if you cross multiply there, and x would be 100 feet. You would know the height of your kite. So you can see why trigonometry could be really useful in a lot of different applications, but we're going to talk more about how it exactly works and how do you know what those relationships are and things like that. So we are going to start by just labeling a right triangle. So the longest side we call the hypotenuse. That side is always opposite the right angle. So that is always going to be the way it is no matter what right triangle you're talking about. The hypotenuse will always be opposite the right angle. The legs, we're going to name them based on an angle in the triangle. So if we name one of the angles in the triangle and call it theta, then the side that is across from theta we will call opposite, and the side that touches theta we will call adjacent. Now that we've named all these sides, we're going to talk about some special ratios that we have special names for in a right triangle with an angle theta. Those are sine, cosine, and tangent. Sine of theta, so the sine of the angle theta is equal to the opposite side divided by the hypotenuse. The length of the opposite side divided by the hypotenuse. The letters, the three letters that help you remember that are SOH, sine opposite over hypotenuse. Cosine theta is the ratio of the adjacent side to theta over the hypotenuse. And the letters you need to remember for that are CAH, cosine, adjacent over hypotenuse, ca. Tangent theta is equal to opposite over adjacent, and so we can remember that using TOA or TOA. These three ratios are the ratios that we're going to talk about, and we're going to be using them to find missing sides and missing angles of right triangles. If you have not learned the trig functions before, it might take you a little while to remember which one is which one. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And those ratios are with respect to that angle, theta. So many people just memorize so, ka, toa, and I can't figure out why that is such a great thing to memorize, because how do you know how to spell so when it has a silent H in it? How do you know how to spell ka when it has a silent H in it? That's not the way I learned the trig functions. I learned the trig functions through this little sentence here. Some old horse came a-hopping through our attic, and that is sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. I made up some more just in case that doesn't work for you, and you can make up your own. Another one is some of her cats are having this odd aroma. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Another one I made up is sorry, our hypochondriacal cousin asked him to operate again. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Another one could be Sir Oliver has called about his tame octopus, Alfred, and that is sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Another one, Sally once heard Calvin and his tiger outside arguing. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. One more. Stop overreacting, Harold. Can't Albert hear? That's odd, Alice. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. You can memorize this in many ways, but the one thing that is definitely true is you have to memorize it. You have to know these ratios so that you can use them to find missing parts of a right triangle. These problems are just to help you get some practice remembering that. So find the sine of angle A. So here's the angle A. And when I write sine, I would never write it by itself unless I was talking about sin, which we don't really do in math class very much. I would always put an angle next to it because it's a function. Sine is a function, and you have to put something into the function, and the function takes angles. The domain of this function is angles, the sine of an angle. Okay, so this angle is A in this right triangle, and we're looking for, remember, opposite over hypotenuse. The side opposite to A is 4. The hypotenuse is 7. So this is 4 over 7, which if you plug it into your calculator, you will get about 0.57. So we would say that's about 0.57. That's the sine of angle A in that triangle. Now we want to find the cosine of B. So you've got this angle. Cosine of B is equal to adjacent over hypotenuse. So in this triangle, if you're looking at B, the adjacent side is down there, 7, and the hypotenuse is the longest side, 8.6. And if you plug that into your calculator, you will get a long decimal. 7 divided by 8.6 is a long decimal, but you can just take the first couple of significant figures, 0.81. So that's about 0.81. Now we want to find the tangent of C. So we have this triangle. Here's angle C. Tangent of C. We would never just write tan because that would just be like when you go to the beach. Tan C. There has to be an angle next to it. All right, so tangent is opposite over adjacent. And opposite is 6. Adjacent is 8. Right? Opposite and adjacent. And so that is 0.75. That's not a long decimal. It's a short decimal. So the inverse trig functions. When you are using the regular trig functions we just talked about, sine, cosine, and tangent, you put in an angle and you get out a ratio. For the inverse trig functions, you put in a ratio and you get out an angle. So in other words, when you take the inverse sine of something, this is what inverse sine looks like. That something is going to be a ratio. So it could be 2 over 3 or something like that. And your answer, what you get, is an angle. So I should have just put the word ratio right here. Ratio. Okay, so when you're using the inverse trig functions, you're going to put in a ratio and you're going to get an angle out. So if I want to find the angle whose sine, and sine is spelled with an E, but we don't usually write it that way. We usually write it S-I-N. We want to find the angle whose sine is this number, and that is a ratio. Even though it looks like a decimal, it's still 643 over 1,000. And so if we want to know what angle has that for its sine, we are going to punch into our calculator 0.643. You're going to punch that in. Then you're going to hit the second key. And then you're going to hit sine. And when you do that, you will get an angle. and that will be the angle that has that sine. So 0.643, second function, sine, and you get about 40 degrees. So the angle that has that sine is about 40 degrees. Find the angle whose cosine is 0.216. To figure that out, you're going to plug into your calculator 0.216. You're going to hit the second function, and then you're going to hit cosine. You get about 78 degrees, okay? So sine, cosine, and tangent, you put in an angle to the function, sine of theta, cosine of theta, tangent of theta, and your answer is going to be a ratio. So opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, you put in an angle, you get out a ratio. For the inverse trig functions, you're going to put in a ratio. That's what the inverse sine looks like. It has a little -1 up there. It's not sine to the -1 power. Not at all. That is called inverse sine. You put in a ratio right here. So you punch that into your calculator, and the thing the calculator will give you is an angle. Okay, in lesson 44, we are going to use the trig functions to find missing parts of right triangles. So here's a right triangle, and we want to find the missing parts. We have one angle, and we can find the other angle without using trig functions at all, because we know that the sum of the angles in a triangle is 180 degrees. When you're dealing with a right triangle, since you already know that the right angle is 90, the other two angles must also add up to 90. 24 plus b is equal to 90. So b is equal to 66 degrees. All right, now we have b. Let's see if we can find the hypotenuse. We have two functions that involve hypotenuse. They are sine and cosine. If we're looking at the angle that is 24 degrees, and we take the sine of that angle, we would have opposite. So I'll write it down. Sine 24 is equal to opposite, which is y, over hypotenuse, which is h. So the sine function in this case is not really going to help me because that's got two unknowns. I can't solve an equation with two unknowns. So sine is no. We're not going to use that. How about cosine 24? Cosine 24 degrees is going to be adjacent over hypotenuse, which is going to be 9.5 over h. Now, that is an equation that I can solve because it only has one unknown. So, the first thing I'm going to do in this equation is multiply both sides by h so that I can get h out of that denominator. So, I will have h cosine 24 degrees equals 9.5. And then I'm going to divide both sides by cosine 24. When I do that, those are going to cancel, and I'm going to have h is equal to 9.5 divided by cosine 24. So I'm going to take my calculator, I'm going to hit 9.5 divided by, and then I'm going to hit 24 cosine equals. And when I do that, I'm going to get that h is about 10.4. I have everything but y. In order to get y, I could use sine now that I know what the hypotenuse is. However, the hypotenuse, remember, is approximated. I did round this number, so hypotenuse is not an exact value. Therefore, I would rather use something that just uses the numbers that are there already, that I know are exact. So if I use tangent 24 degrees, that is going to be opposite over adjacent. And opposite to 24 is y. So tangent 24 is equal to y over adjacent to 24 is 9.5. So that way I didn't use any numbers that were rounded, and so my answer will be more accurate. Multiply both sides by 9.5 and you get y. If you punch that into your calculator, you'll have 9.5 times 24, hit tangent, then equals, and you get that y is about 4.23. All right, if we just write some of the ratios for 35 degrees, sine 35 degrees is opposite over hypotenuse, which is x over 14. That has only one unknown, so that is an equation I can solve. I'm going to multiply both sides by 14, and you get that x is about 8.03. Now, I could find m using the Pythagorean theorem, but again, I don't really want to do that because x is an approximated value. And therefore, when I use the Pythagorean theorem to find m, I'm using one number that's really not exact. So I'd rather use numbers that I know for sure are exact, like 14 and 35 degrees. And I can find b because I know that 35 plus b is supposed to be 90. And so b is going to be 55 degrees. I can use that angle, or I can use the 35-degree angle to figure out something about m. If I try to use sine 35, well, we already tried that. It doesn't have m in it, so that's not going to work. We could try sine of 55. So we could use this angle, which we just found out is 55, and that was an exact amount. So the sine of 55, which is the sine of b, is equal to m, opposite, over hypotenuse. So that works. 14 sine 55 is equal to m. And I will get that m is about 11.47. Here's another one. Find the missing parts. Now we don't know either one of the angles. Find angle A. Let's see what we need to do to find angle A. What do we have related to angle A? We have the adjacent side and we have the hypotenuse. Which trig function involves adjacent and hypotenuse? That's going to be cosine. So cosine of A is going to equal 6 over 7. Now, when I don't know what the angle is, I use inverse cosine. So I'm going to use the inverse function to find the angle whose cosine is 6/7, and that will be A. So let's punch this into the calculator. We're going to have to hit 6 divided by 7, and then we're going to have to hit equals because we need the calculator to know what ratio we're talking about. Then we hit second function, cosine, and we get that A is about 31.0. It's not exact, but it's close. Now that we know what A is, we can use that to find B. We just know that B is going to be 90 minus 31 degrees. But again, since 31 degrees is not exact, we could just go ahead and use another trig function to find B. So if this is the angle we're looking for, we have the opposite side to B, we have the hypotenuse. So we could use sine to find B. Sine B is equal to opposite over hypotenuse. So to figure this out, we have to use the inverse sine function. We'll put the ratio into the function, and that gives us the angle back out. So again, we're going to hit 6 divided by 7 equals, have to hit the equal sign, hit second function, sine, and we get about 59 degrees. So B is about 59 degrees, and that's what we would expect because 59 plus 31 is 90, and the two angles that are not the right angle are supposed to equal 90, so therefore the inside angles of the triangle add up to 180. To find x, we have many ways we could do that. We could use the Pythagorean theorem, or we could use a trig function. Now we did find A and B, but they're not exact answers that we had to round them. So probably the most accurate way to find x is to use the Pythagorean theorem. So 6 squared plus x squared is equal to 7 squared. 36 plus x squared is equal to 49. Subtract 36 on both sides. X squared is equal to 13. And so x is equal to the square root of 13.